Hi students, previously we discussed with the basic concepts of trigonometry and even identities and the values of these trigonometric ratios for some angles 0, 30, 45, 60 and 90. Now let us have some numericals to be done today. Let us take the first numerical. In triangle ABC, right angled at B, AB equals to, has given it as 24 centimeters. BC equals to 7 centimeters. Now he's asking us to determine first one sin A, second one cos A, and even third one sin C, and fourth one it is cos C. As we know the Pythagorean theorem, let us draw the triangle first. Here we are given ABC is a right angled triangle which is right angled at B. Okay. Now let us say A, B, C, right angle at B, it is 90 degrees. The side opposite to right angle in a right angle triangle is called hypotenuse. And the value of hypotenuse, he did not mention here. Okay, AB is given as 24 centimeters, BC is given as 7 centimeters. Now let us apply Pythagorean theorem. From Pythagorean theorem, we can write the square of hypotenuse is equal to the sum of the squares of other two sides. AB square plus BC square. AC square equals to 24 square plus 7 square. AC square equals to 24 square, it is 576 plus 7 square, 49. AC square equals to 576 plus 49, it is 625. AC equals to square root of 625. Square root of 625 we get generally as plus or minus 25, but we never calculate the lengths in terms of negative. Hence, we take it as 25. Therefore, we got the value of AC as 25 centimeters here. Okay. What did he ask us to find? Initially, he asked us to find sin A. Okay. For this angle, you see, this is hypotenuse anyway. For this angle A, this BC becomes the side opposite and AB becomes the side adjacent. Hence, sine of any angle is nothing but opposite by hypotenuse. Sine A equals to opposite to A. Here it is BC by AC. Therefore, sine A equals to BC value is 7 by AC it is 25. Anyway, centimeters they get cancelled off. Similarly, cos A. Cos A equals to adjacent side to A by hypotenuse. Cos A equals to adjacent side to hypotenuse. It is adjacent side to A. It is AB by hypotenuse AC 24 by 25. Now, the third thing he asks us is to find, this is the first one, this is second one. The third thing he asks us to find is sine C. Now, for angle C, this adjacent and opposite changes. Hypotenuse remains the same, as the hypotenuse is the side which is opposite to right angle in a right angle triangle. అయితే ఇప్పుడు మనము C angle కి opposite ఏముంది, AB ఉంది. This side becomes the opposite. And adjacent ఏముంది, BC ఉంది. Hence we take sine C equals to opposite, that is AB by hypotenuse AC 24 by 25. Cos C adjacent to C by hypotenuse. Adjacent to C is BC by hypotenuse, it is AC, which equals to 7 by 25. These are the values he asks us to find: sine A, cos A, sine C, cos A. And when we are talking about A, opposite and adjacent changes. For angle A, the opposite side is BC and adjacent side is AB. For angle C, the opposite side is AB and the adjacent side is BC. The hypotenuse remains same, as it is the side which is opposite to right angle always. Okay, let us take the next problem. In the following figure, find tan P minus cot R. This is the figure he has given us. P, Q, R. This is the angle, 12 centimeters, 13 centimeters. We are not given the value of QR. Okay. Now, again, according to Pythagorean theorem, this is our hypotenuse, PR. We can write PR square equals to PQ square plus QR square. PR square in the sense 13 square equals to PQ square 12 square plus QR square. 169 is 13 square. 12 square, it is 144 plus QR square. Now, if I make QR square as subject, then QR square equals to 169 minus 144. Obviously, 169 minus 144, 9 minus 4, it is 5. 16 minus 14, 2. QR equals to square root of 25. We got its value as 5. Now, he asked us to find value of tan P and cot R. Initially, for P, for angle P, the side opposite becomes QR and adjacent is PQ. Let us find tan P. Tan is nothing but the opposite side to theta by adjacent side to theta. That is QR by PQ. QR by PQ. QR we got it as 5 centimeters, right? 5 by it is 12. Now he asked about cot R. Now the story changes here. For R, for angle R, PQ becomes the side opposite and QR becomes the side adjacent. That means what is cot of an angle? It is adjacent to angle by opposite to angle. Adjacent to angle, it is, okay, let us write in terms of this one. QR by opposite to angle, it is PQ. The same thing, 5 by 12. Hence, the value of tan P minus cot R, it is 5 by 12 minus 5 by 12, which equals to 0. We need to always check out the hypotenuse remains the same, whatever might be the angle we are asked about. But according to the given angle, the side opposite and adjacent always changes. We need to consider that. Let us move on to the next problem. Third one, if the problem given is if sine A equals to 3 by 4, find cos A and tan B. This is the question. Okay. We are given sine A equals to 3 by 4. Let us draw the triangle. Because we are taking all these things in terms of ratios, this is a right angled triangle. Let us say right angled at B. And this becomes hypotenuse for angle A. This is opposite and this is adjacent. Now he has given the opposite in terms of ratios, of course, he has given, but we can take the values directly as we are going to find the ratios only, because cos and tan are also the ratios. Hence, we can take these values directly. Instead, Sometimes whenever we are given the ratio, we take some other constants or as their multiples, like 3k, comma 4k, or 3x, 4x. But because we are going to find the ratios, we can take the values directly here. Hence, we are asked to find cos A. Cos A is nothing but cos adjacent side to theta by hypotenuse. AB by AC, 4 by, okay, initially we need to find the value of hypotenuse, right? Okay, let us find its value. From Pythagorean theorem, we can write AC square equals to AB square plus BC square. AC square equals to AB square 4 square plus 3 square. AC square equals to 16 plus 9. AC value is 25. Therefore, AC value we got it as 20. AC equals to square root of 25. It is 5. Hence, AC value it is 5. Therefore, cos A value is 4 by 5. Similarly, tan A, opposite side to theta by adjacent side to theta. What is opposite side to A here? BC. Adjacent side to A, AB. That is 3 by tan, opposite by adjacent. Oh, sorry, here we made a mistake. Sine is nothing but 3 by 4 he has given, right? Wait a bit. Sine A equals to 3 by 4. Opposite it is 3 and hypotenuse it is 4. Now we are asked to find, okay, from Pythagorean theorem we can write AC square equals to AB square plus BC square. AC square it is 4 square equals to AB square. We need to find out the value of AB plus BC it is 3 square. And if I make AB square as subject, we get 4 square minus 3 square. AB square equals to 4 square it is 16 minus 3 square it is 9, or AB square equals to 16 minus 9 it is 7. Hence the value of AB is root 7. Okay, now we got the value of AB as root 7. Let us find cos A. Cos A is nothing but the side adjacent to theta by hypotenuse. Here the side adjacent to theta is AB by hypotenuse, it is AC. Root 7 by 3. Similarly, tan A, it is the side opposite to theta by adjacent to theta. Opposite to theta, it is BC. By adjacent to theta, it is AB. Here AC value is 4, right? BC, it is 3 by root 7. If you want, you can rationalize it into root 7 by root 7. That is 3 into root 7 by root 7 into root 7 is, it is 7. Okay. Let us go on to the next problem. Emma, any doubt?
Actually, in the question lo cos A and tan A, sir.
Cosine tan A. Cos is adjacent by hypotenuse, tan
Yes, sir.
is opposite by adjacent.
Okay. In question.
Now, next thing we are given 15 cot A equals to 8. Find sin A, comma, secant A. Okay, given 15 cot A equals to 8. If we transpose that 15 under multiplication to that side, we get it as 8 by 15. Let us take the triangle now. A, B, C, right angle at B. Opposite, the side opposite to right angle is hypotenuse. Now for this angle A, this becomes the side opposite and this becomes the side adjacent. As given, we know cot is nothing but adjacent by opposite, 8 by 15. Adjacent it is 8 and opposite it is 15. Now sin A equals to opposite by hypotenuse. Opposite it is 15 by hypotenuse. It is we didn't find the value of hypotenuse again. Let us use Pythagorean theorem. AC square equals to AB square plus AC square. AC square equals to AB square, it is 8 square plus 15 square. AC square equals to 8 square, it is 64 plus 225. AC square equals to 5 plus 4, 9. It is 289. AC equals to square root of 289, which is nothing but 17. Hence, we got the value of hypotenuse as 17. And sin A equals to 15 by 17. And even we are asked to find the value of secant A. Secant A is nothing but hypotenuse by, as it is reciprocal of cos. Hypotenuse by adjacent. Hypotenuse anyway we have its value as 17. By adjacent it is 8. Okay. Is it clear? Let us move on to the next problem. Given secant theta equals to 13 by 12, find all other trigonometric ratios. This is a right angle, a triangle. A, B, C, right angle at B. The side opposite to right angle is hypotenuse. Now let us say this angle as theta. Then the side AB becomes the side opposite to theta and BC becomes the side adjacent to theta. We are given secant theta equals to 13/12. But secant theta equals to hypotenuse by adjacent. Equals to 13/12. Hypotenuse it is 13, adjacent it is 12. Okay, let us find AB by using Pythagorean theorem. AC square equals to AB square plus BC square. AC square, okay, AC value we have here. 13 square equals to AB square plus BC square, it is 12 square. 169 equals to AB square plus 144. If I make AB square a subject, then we get 169 minus 144. AB square equals to 25. Or the value of AB is root 25, which is nothing but 5, as we know. Now we are asked to find all the other trigonometric ratios. If you get AB, we can find easily all the other trigonometric ratios. Let us see how to find those things. Okay. First is sine theta, that is opposite to theta by hypotenuse. Opposite to theta, it is 5/13. Next is cos theta. You can write even the formula, or cos is nothing but the reciprocal of secant. You can write it directly. That is 12/13. Tan theta, opposite by adjacent, or sine by cos. Anything you can write. Opposite by adjacent, that is 5/12. Cosecant theta is hypotenuse by opposite or reciprocal of sine theta. 13/5. Secant is already given. The last one is cot theta, which is nothing but the reciprocal of tan theta. That is 12/5. Hence now we found all the values when secant theta is given, we found all the other values. Okay. Now this is the thing. Basic concepts of trigonometric ratios are very, very important. Sine theta equals to here Pythagorean theorem plays a major role in finding the other side, the third side when the two sides are given. Yes, the square of hypotenuse is equal to the sum of the squares of other two sides. And even sine theta is, and even finding out which is opposite and adjacent is also important. That changes. అది చేంజ్ అవుతుంది. ఇప్పుడు మనం పర్టికులర్ యాంగిల్ ఏదైతే తీసుకున్నామో దానికి ఎదురుగా ఉన్నది we take it as opposite side, then side కి ఉన్నది we take it as adjacent. Sine is opposite by hypotenuse, cos adjacent by hypotenuse, tan sine by cos opposite by adjacent, cosecant reciprocal of sine hypotenuse by opposite. Secant reciprocal of cos, hypotenuse by adjacent, and cot reciprocal of tan, adjacent by opposite. And some more numericals we are going to deal in the next session. Until then, this is Santhosh from Sims Academy signing off. Take care. Bye bye.